Today, we're going to look at something really cool in AI. It's an idea that's not about finding one single perfect answer, but about creating whole armies of diverse, super high-performing solutions. We're diving into a breakthrough called PBT map ELITES, and trust me, it's a real game changer.
So, think about this for a second. When you're trying to solve a really tough problem, what do you usually go for? You're probably looking for that one best solution, right? But what if that's not the best way to think about it? What if having a bunch of different good answers is actually way more powerful? And that question leads us right into this really powerful concept in AI called quality diversity. It pretty much flips the whole script on what it even means to solve something. So here's the big idea. Instead of spending all this time searching for one single champion, one perfect algorithm, quality diversity is all about generating a whole collection of solutions. And these solutions aren't just good, they're also fundamentally different from each other. Think of it like building a whole team of specialists instead of just trying to hire one single superstar. I mean, it makes sense, right? This is so important for real-world problems because if your one superstar solution fails, you're toast. A diverse team gives you options. It gives you robustness. And this is the perfect example. Just look at these AI-controlled robots. They were all given the same simple task: move forward as fast as you can. But instead of discovering one single best way to walk, the AI came up with this huge variety of really effective styles. Some are kind of like scuttles, some are hops, others are almost like limps. And you know what? None of them are wrong. They're all just different, high-quality answers to the exact same problem. Now, to get this kind of amazing creative diversity, researchers tried mixing two of the most powerful ideas in AI. It was a super promising approach, but it came with some pretty serious hidden flaws. Okay, so on one side, you've got these evolutionary algorithms, specifically one called map-ELITES, which is fantastic at creating diversity. And on the other side, you've got modern reinforcement learning, or RL, which is incredibly good at finding high-performing solutions. It uses what's called gradient information. You can just think of it as a much smarter, more focused way to search. The idea was, hey, let's mash these together and get the best of both worlds. And, at first, it worked. The search for solutions got way more efficient, but it came at this huge cost. These new hybrid methods turned out to be extremely sensitive to their initial settings. All the little knobs and dials an engineer has to tune, which we call hyperparameters. If you got them just a little bit wrong, the whole thing would just fall apart. They were unstable, they were hard to scale, and the results were just all over the map. Now here's the really ironic part. As the researchers themselves point out in the paper, by mixing in reinforcement learning, they actually brought back the very same problems, like instability and sensitivity, that the original evolutionary methods were specifically designed to get away from. Kind of a back to square one moment. So, all of this frustration led to a major breakthrough. To fix the problem, the researchers decided they needed a fundamental shift in their thinking. They decided to stop just evolving the AI's strategy and start evolving the entire AI itself. You see, the old way was focused only on evolving the AI's policy, and that's basically just the brain, the neural network that decides what to do next. It was kind of like trying to find the best playbook for a sports team while keeping the players and coaches the same. But the new idea, PBT map ELITES, was to evolve the entire agent. And this means not just the playbook, but also the coach, the training schedule, and even the rules for how the team learns and adapts over time. It's a meta-learning approach. You're not just learning a task, you're learning how to learn the task. Okay, so let's break down how this new idea actually works. Over on the left, you've got a whole population of agents. But here's the absolute key. Each one has its own unique set of learning rules, its own hyperparameters. As they get tested out in the world, the best and most unique ones get added to that grid on the right, which is kind of like a hall of fame, a repertoire of elite solutions. New agents are then created by pulling from this elite group, so you're constantly mixing high performance with high diversity. It's brilliant. So the big question is, does it really work? To prove it, the researchers gave this new AI a notoriously difficult challenge, a deceptive problem that almost always fools simpler algorithms. This is the humanoid trap. It looks simple. The robot gets points for moving forward. But see that pit? Right in front of it is a trap. The easy, greedy thing to do is just go straight, which always leads to failure. The only way to win is to explore, to realize the trap is there, and to creatively find a way to get around it, even if that means moving sideways and losing some points in the short term. And the results were, well, they were stunning. This chart shows the maximum score the AIs are able to get. The previous methods, they get stuck. They can't figure it out, and they max out below a score of 2,000. But PBT, Map Elites, it didn't just solve it, it absolutely crushed it, getting a score over 5,000. It consistently learned to sidestep that trap every single time. It's not even close.
So this is what that success actually looks like. On the left, you've got that deceptive trap problem, and on the right, that's the outcome. That's the map of elites. Every single one of those bright dots represents a unique, high-performing AI that found its own creative way to solve the puzzle and get around the trap. It's not one solution, it's an entire landscape of them. And this is maybe the coolest part, how it solved the problem. This visualizes one of the agent's internal settings, its exploration noise. At the start of training, the agents that did well evolved to have high exploration noise. That's the bright yellow and purple colors. This made them wander around and eventually find a way past the trap. But later on, once they'd figured it out, they evolved to have low exploration noise, those dark blue areas, which let them perfect their path and really max out their score. The AI literally taught itself how to learn better for this problem. So what does this all mean for the big picture? I mean, this isn't just about making virtual robots walk better. This is a massive step forward for what we could call creative AI. So if we boil it down, what makes this PBT Map ELITES such a breakthrough is a few key things. 1, it's way more robust. It's not so fussy about its settings. 2, it's more flexible, so you can pair it with pretty much any reinforcement learning algorithm out there. And 3, and this is huge, it's automatically tuned. It figures out its own best settings as it goes, which takes a massive headache away from the human trying to use it. A framework like this really opens the door to using AI for all sorts of complex, real-world problems where there just isn't one right answer. Think about generating thousands of potential new engineering designs, or creating diverse business strategies, or even discovering new scientific ideas. It's all about generating a rich set of options, not just finding a single, lonely optimum. It really leaves you with a powerful question to chew on, doesn't it? We just saw an AI discover a whole universe of creative ways just to walk. So what happens when we point this kind of creative, diverse, problem-solving engine at the truly complex challenges we're all facing next?